So I'm going to go over paper 2H, okay? So it's January 2020, paper 2H, all right? So what I've done is I've broken this paper up into several different video files, so there's not a big one to upload, okay, because it could take a long time, all right? And also it might be that at some point later on you want to just go through individual questions and you can just open the right one, all right? But what I would suggest you do is you go get your paper now. If you haven't got it, pause the video, okay? Go and get your paper, and what I'd like to do is check your answers for me, please, with what I'm going to go over on this board, all right? So question 1, A should be x to the power of 7, should be simple enough, and B should be 7 to the power of 9. I'm hoping no explanation is necessary, okay? Question 2, right, you can see this cube I've drawn out, okay, so just to give you a demonstration as to why you multiply 32.4 by 1 million, okay? So if this is 1 metre cubed, what that means is the dimensions are each 1 metre, 1 metre, 1 metre, okay? Which of course is 100 centimetres each. Now if you do the multiplication, 100 times 100 times 100 is a million. Okay, so that's why 1 cubic metre is 1 million cubic centimetres, all right? So what you do is times that by 1 million and you get 32,400,000, okay? So that was question number 2, all right? So moving on, question number 3. So this is a show that question. Right, so what that means is you need to set out your working in a very particular way, right? And let me just show you what that method is. What you should be checking is that you're setting your working out in a similar way, okay? If you're not, can you just make the additional notes for him, please? So question 3, 4 2/3 plus 3 4/5. What you're going to show that that is equal to 8 and 7 over 15. Okay, so you can see how I've set it out already. You start with the left hand side and you write down each individual step of working, each individual stage, and that should be a final answer. Never write that equals 8 and 7/15. Okay, don't. You might be able to get away with it in GCSE, but you won't in A-level. Okay, so good habit, write down left hand side and just try and get to that. So what you've got to do is try and simplify this each step of the way. So there's a number of ways you can do this, okay? What I'm going to do is I'm going to turn these into top-heavy fractions, okay? So that's going to be 12 plus 2, 14 thirds, and this one is going to be 15 plus 4, 19 fifths, okay? So you don't have to, but that's the way I've done it, okay? Then you want a common denominator, okay? So that denominator is clearly going to be 15, all right? So I'm just going to write that as 15, and then 14 times by 5, that is 70, and 19 times by 3, that is 57, okay? And then next add them together, so 70 plus 57 is 127 over 15, and then just check, 120 divided by 15 is 8, and that is equal to 8 and 7/15. So yeah, that's all you need, okay? You don't need any more than that, and that'll be enough for the full marks, okay? Right, moving on, question number 4. There we go. So what you need to do is add each of the angles together, and so that equal to 180 degrees. I'm hoping that's obvious, okay? So write out 4x plus 10 plus x plus 20 plus 30 equals 180 degrees. I know it's an easy question. You're probably thinking, why is it worth 4 marks? But you get a mark for that, you see. And then another mark for simplifying this. So that'll be, what, 5x plus 30, 50, 60, okay, equals 180. And then that'll be 5x is equal to 120. And then that'll be x is equal to 24. Okay, and then, yeah, that's it. So nice and simple, hopefully. Question number 5. So construct the bisector. So I'm just going to demonstrate this, okay? So imagine that's what you've got, okay? And you want to construct a bisector. So let me just show you how to do this, okay? So imagine this is your compass. Open your compass and then do not adjust the width, okay? Not adjust the radius. Keep the distance between the point and the pencil the same throughout, okay? Put your compass point on there, and with your pencil, make an arc there and there. And then put your compass on here, make an arc somewhere in the middle, and then there, somewhere in the middle again, and they'll cross over at some point, okay? What you then do is with a straight line, you join that vertex, that corner, to where they cross. And that should bisect it. I know it's not on my board because I've not used a compass ever. That's the whole point of a compass, okay? When you use a compass, it will be exactly. You can check by measuring the protractor, but those should be equal if done properly. Okay? Well, that's the first 5 questions, so I'm going to stop it there, and coming up will be the next lot. Okay, so question 6, let me just talk you through how to do this, okay, using that algebraic approach. So when it says the probability the bead is green is twice the probability to be red, what you do is assign the probability of red as being x, okay, because it's unknown, and then the probability of green would then be 2x, okay. So if you couldn't get it, because some of you might have guessed the numbers or used trial and error, that's fine, but if you can't, then this is what you do. So x and 2x, and then what you do is add all those together, so x plus 2x is 3x, okay, and then that plus that is 0.55, that should total 1, you see, and so then you have 3x is equal to 0.45, and then x is equal to 0.15, and then that's what you do, okay. So what that means is that the red, you can write that down as 0.15, and the green, you can write that down as 0.3. So I'm hoping that made sense to you, okay. So what happens next? So she writes down the colour, does it 180 times, estimate the number of times it takes a red. So the red was 0.15, okay, so multiply that by the number of times you do it, which is times by 180, okay, and you should get 18 plus 9, 27. Okay, 27, okay, and then that's it. I'm hoping that was fine for you. Next, question number 7, so this is an inequality question. Now remember, with inequalities, you treat it like an equation. Just make sure you, even though you're solving like an equation, write the correct inequality symbol in. Never use the equal sign. Okay. So you have got 2x plus 7 is greater than 4. So then you have 2x is greater than negative 3. Then x is greater than negative 1.5, or negative 3 over 2. And then part B, solve x squared minus 3x minus 40, okay, equals 0. Bit of a hint, if it doesn't say round it to 3 significant figures, it's likely that this one will factorise, okay, so try and factorise that then. So 8 and 5, I think the numbers we're looking for, because 8 times 5 is 40, and you can make the number 3 from 8 and 5. So it'll be x subtract 8, and then x plus 5 equals 0, so x is equal to negative 5 or 8, okay. And that is it. Okay, you better have found that question easy, because you're in trouble next year if you want to do A-level if you didn't find that easy. Right, next, question number 8. This is a really wordy one, isn't it? Let's have a look. Okay, so what you want to do is work out the percentage increase from 2016 to 2017. And the percentage increase from 2017 to 2018, and compare. Alright, so that's what we're going to do. So the first percentage increase then, so the 2017 figure is 545, okay, and the 2016 figure is 500, 2018 figure is 592. So for an increase, work out what the increase was. So from 2016 to 2017, the increase was 45. And then to find the percentage, write that as a fraction out of the original amount. So remember, I'm doing 2016 to 2017. So 45 over 500, and to turn it into a percentage, times it by 100. Okay, so 45 over 500 times by 100. Okay, so that is equal to what? Well, that's going to be 45 over 5, isn't it? With the hundreds cancelling, so that's going to be 9. So that's the 9%. That's the first one. So then for the next 2 years, so work out the increase, 545 to 592. That's 47. Okay, so 47 is the increase out of the original amount was 545, and then turn it into percentage times by 100, and that gives 8.6%, and then you compare. All right. So obviously this one is higher. So is Brigitte correct? She said that this figure was more, so no, she's wrong. Okay. So therefore, just put she is wrong. Remember the conclusion. You don't get full marks for just that and that. You've got to write, she is wrong. Okay. Next, part B. Right. So Henry wants to insure his car. He gets a discount, 15% off the normal price. He pays €952 for his car insurance after the discount. Okay. So this is something where you've got to work out the original amount effectively. When it says he paid it after the discount, what that means is with the discount, the final total he pays is 952. If that makes sense. So 15% off means the decimal multiplier is 0.85. So when you want to take 15% off of something, you times by 0.85. Okay, let's call the amount X, and the amount he's paying is 952. Does that make sense to you? So 15% off of an amount is equal to 952. So can you see how to work out what the original amount was? You've got to divide by 0.85. So divide by 0.85, you get 1,120. So that's how much the full cost was before the discount. All right. So work out the discount he gets. So you've got to find the difference between that 1,120 and the amount he paid, 952. Okay, and that gives us 168 euros. Okay, hope that makes sense to you. Next, question number 9, density. All right, very good. Hopefully you remembered your density formula. A bit like speed, distance and time, there's a density, mass, volume triangle you can use. Okay, so remember density is mass divided by volume. Okay, how can you work that out? Well, look, it says in the question here, density is 19.3. Look at the units. Okay, the units are grams per centimetre cubed, and I've written it out like that now on purpose. Okay, grams is a measurement of mass. Okay, and centimetres cubed is a measurement of volume. Yeah, and it says the density is that. So that's a nice way of getting what the density mass volume formula is, just by considering the units. Okay, it's quite nice, isn't it? Okay. So the actual density mass volume triangle is, let me get this right, so it's mass at the top, and it's density, and it's volume, because what you then do is you cover up the one you want. So for example, density is mass over volume. Okay, but rearrange that formula, you can see that mass is equal to density times by volume. They're covered up, density times by volume. Okay, so what you want to do is you want to do 19.3 multiplied by 150. Okay, and then write down your answer. That turns out to be 2,895. There's no decimal point, I was misreading it. 2,895 grams. Okay. Right, question number 10. Change a speed of 50 meters per second to a speed in kilometers per hour. This is quite an important question because, when we're travelling in cars, we use kilometers per hour, don't we? However, when you do mechanics questions, which you'll see when you do A-level maths, okay, the units we tend to use, the SI units, System International, they're meters and seconds, or meters per second. Okay, so when you do your calculations in A-level maths, you've got to use meters and seconds, so you get answers in meters per second. But then when you want to relate it to the real world, you want to convert it. Okay, so no, you start off with 50 meters per second. The first thing you want to do is maybe change that into per hour. So if you're doing 50 meters each second, each minute you're doing that 50 times 60, and then each hour you times by another 60. Okay, so 50 times 3,600, that gives you 50 meters per hour. All right, and then if that's per hour, to get per second, you want to say that again. If that's per hour and you want to get into kilometers, okay, what you do is change the 50 meters into kilometers and you divide by 1,000. There you go. I thought I lost the plot for a moment. Okay, so 50 times by 3,600 divided by 1,000. Okay, and that gives you 180 kilometers per hour, which is, it's reasonably fast, isn't it? Okay, it's reasonably fast. Okay, right, I'll stop there, and the next set of questions are coming up. Okay, this is question 11. Okay, you've got to work out the perimeter of this shape. So obviously you're going to have to do 17 plus 15 plus, and then this. Okay, that's a semicircle. Right, so you've got to work out what the circumference of the circle is and half it to get the distance of the that circular arc, the arc length. Okay, to do that you need the radius or diameter. So you need to have this length here, and I'm just going to tell you that that length is obviously 8. Now you might think, why is it obviously 8? Now maybe you use Pythagoras Theorem to do it. I hope you did, okay? But what I'm going to tell you is that this is a Pythagorean triple. Do you remember what those are? A Pythagorean triple is a set of 3 integers, positive integers, such that the first two, when you square them and add them together, gives you the third one squared. Okay, so another one is 3, 4, 5. Can you see how that works? 3 squared plus 4 squared is 5 squared. Okay, and yeah, 8 squared plus 15 squared is 17 squared. Okay, there's another one, 7, 24, 25. Somebody might need your calculator for that to check, but yeah, 7 squared plus 24 squared is 25 squared. And there are lots of others. They're called Pythagorean triples, and if you know a few, it can just make it easy to answer these questions. So for example, somebody may have spotted that as a Pythagorean triple. If you didn't, not to worry, use Pythagoras Theorem and you get 8. Okay. Well, the circumference of a circle, of course, is this. Circumference equals pi times diameter. So what you'd have for a full circle is you'd have pi multiplied by 8. Okay, but you want to half that, don't you? You want to half that to get the arc. So half of that is just 4 times by 8. So what I'm going to do is I'm going to write down by here plus 4 pi. So the exact answer would be 32 plus 4 pi, but they want us to round it, okay, to 3 significant figures. So that's 44.6. Okay, 44.6. Okay, hopefully you found that helpful. Right, moving on. Question number 12. Plenty of scope to make a mess of this question. Okay. But the thing is, you've probably all done a slightly different method. Okay. And just talk you through what I would do. Okay. So you've got Dane oil, which I imagine is Danish oil. Someone will correct me if I'm wrong, but I imagine it's Danish oil. And then you've got Arctic oil, which must be Arctic. Yeah. And you've got how much it costs in krona and dollars. Yeah. So okay. And you've got a conversion rate, $1 is 6.57 krona. Okay. From which companies you should buy oil. Basically, which one is the better value, okay, is what you want, okay? Right, so look, given that the exchange rate says $1, so that's the dollar symbol, equals 6.57 krona. I'm using capital K. I don't know if it's KR, but I'm using capital K. Is that all right? I hope you don't mind, okay? Right, given that, what I'm going to do is I'm going to look at the Arctic oil figures, okay? And look at the Arctic oil figures. And what I'm going to do is, using their rate, 8.6 times 10 to the 5 litres is $770,000. I'm going to work out at that rate how much it would cost for the Danish oil, okay? So for the Arctic oil, it costs $770,000, okay? And what I'm going to do is I'm going to work out at that rate how much it costs for the Danish oil, okay? Now that will give me 8.6 times 10 to the 5 litres. If I want to buy 4.2 times 10 to the 5 litres, okay, what I'm going to do is I'm going to divide that figure by 8.6 and multiply by 4.2. And then that should give me the volume amount for the Danish oil. Does that make sense? Yeah? So the $770,000, okay, if I divide it by 8.6, that tells me how much it costs per 10 to the 5 litres. And then if I times by 4.2, that tells me how much it will cost for the Danish oil, but in US dollars. Okay, so I'm going to work out what that is. Okay, and I did that previously, as you can tell. That gave me $376,000 and 46.51 ... kept on going. Okay. Now, that's how much it should cost in US dollars. I'm going to use this exchange rate. Okay, so what I'm going to do is I'm going to put some work in over here. I'm going to times that by 6.57, okay, to get what it should be in this Danish krone. Okay, and that turns out to be 2,470,625.58, and I've rounded it. Okay, krona. And I'm going to compare with what it says it should be. They reckon it's 2,500,000. Well, that comes in as a bit cheaper, doesn't it? Okay, so what that means is this figure is cheaper, so the Arctic oil is cheaper. So I'm going to make it clear there. Therefore, Arctic oil is cheaper. Okay, you might have done it using a different method, but I'm hoping that method makes some sort of sense to you. Okay. Right, moving on. Question number 13. The circle theorems. Okay. Remember, I keep on saying you need to revise your circle theorems. you need to basically know what the theorems are and be able to quote them. And when it says give a reason, you've got to write down the theorem in words. All right. So what I'll do is just a quick sketch of this. Just bear with me while I try and draw this out. Okay. So can you see there? That clearly goes through the centre of the circle. So that means that that is a diameter. All right. Now if I just join up to point C, just as a bit of a hint, can you see already that you can use a circle theorem there without even reading the question? Okay, that is the angle in a semicircle rule, isn't it? And that must be 90 degrees. So one of your reasons, I imagine you should write down at some stage, is that ACD is 90 degrees, and then angles in a semicircle. I've started, so I'll finish at 90 degrees. And look at that, my pen has just had enough. Okay, goodbye to that pen and hello to this pen. Okay, so angle semicircle down to 90 degrees. All right, so that's that one. Let me just complete the rest of the diagram for you. So you've also got another angle here, and it's joined to that. Okay, so that angle is 28 degrees. Okay, can you see that angle there is also 28 degrees? Okay, do you remember the circle theorem? Angles in the same segment are equal. So when you've got basically this kind of shape, those two are equal. Okay, and those two there would be equal as well. So I'm going to write that down as well. So that's, what was that? That was this one, D, AC equals 28 degrees, and angles in same segment are equal, and then that will do. What else were we told? Oh, we're told that angle there is 32 degrees. Okay, so that looks like 320. Obviously it's not, but I want it to look like 32 degrees. And we've got to work out what BDC, oh crikey, where's that? BDC, so that angle there. Okay, so BDC, we've got to work out what that is. Okay, you can just write down the answer if you want, just give the reason. Okay, but in this triangle here, that plus that must equal 180 degrees. Okay, so you got 28 plus that must be 180 degrees. Okay, so oh, sorry, no, I thought it didn't look right. That's not 90. That's the end that's 90, isn't it? Okay, so all right, so that triangle there, that's the one I meant. 180 degrees, yeah, it looks a bit better. So 28, 90, that plus that. So let's just call that theta, shall we? So we're going to say that 90, I'll tell you what, show some work in here, 90 plus 32 plus 28 plus theta equals 180 degrees. So 32 plus 28, simple, isn't it? So it's 60. So 90 plus 60 is 150. So 150 plus theta is 180 degrees, and so that means theta must be 30 degrees, and the reason I'm going to write is angles in a, you should write out the word triangle, add to 180 degrees. Okay, and that is it. Okay, it says give a reason for each stage. I would recommend you write down those three reasons there. Okay, is that okay for you? I really hope so. I'm going to pause it there because it took me a while to go over those questions. Okay. Okay, number 14. All right. So 20 glasses in the cupboard. 13 are large, 7 are small. So quite easy. You can put in here for the large. It's going to be 13 over 20, and for the small it is 7 over 20. Now Roberto takes 2 glasses from the cupboard. Okay. What that means is he doesn't take 1 glass and then put it back, because that'd be silly. Okay, if you need 2 glasses, think about it. He takes 2 glasses. Now the way you've got to think about this in maths is you would imagine that Roberto takes 1 glass and then he takes another. I know realistically we'll probably just take 2 glasses at once. Okay, but in maths you've got to think of it as takes 1 glass, then takes another glass. Okay, so take the first glass, it's these, and then take the second glass. If he's taking a large one first, that means there's 12 over 19 chance of taking a large one second. Hope that makes sense. Okay. And if you take a large one first, again, for the small, it's going to be 7 over 19. Always check that those two and those two add up to 1, okay, because they cover all possibilities. If we took a small glass first, then it's 6 out of 19 here, and that will be 13 out of 19 there. And that's the tree diagram completed. Okay. Part B, probability that Roberta takes 2 small glasses, so there we go, small and small again. So 7/20 times by 6/19 and gives us our answer. Okay, that will be 21 over 190. Okay, when you simplify the fraction. Okay, hopefully that was helpful to you. Let's move on to the next one. So what's question 15 all about? Oh, graphs. Okay, good. You can probably guess these, but I hope you didn't. I hope you fully understand what is going on with each one of these graphs. Okay, it's quite a good question, I have to say. Alright, so the first one, y equals 2 over x squared. Okay, y equals 2 over x squared. Right, the thing about this is, okay, the graph is always going to be above the x-axis. Okay, because that is always going to be a positive number. It's never ever going to be 0. You can never put a number in to get 0, and x squared is always going to be positive. Okay, so you're always going to get a positive value. Okay, so what you do is you're looking at the graphs to see which one is always above the x-axis. There's only one of them. It's graph C. Okay, it's graph C. Okay, so the first answer is graph C. Okay, right, next one. Y equals negative 1/2 x cubed. Okay, so a cubic graph looks something like this. That's the graph of y equals x cubed. Okay, but that's negative x cubed. So what you want instead is you want to have this one. Okay, remember the transformation there? It gets reflected through the x-axis. Okay, so you want this shape there, and that shape is graph B. Okay, so that's graph B for the second one. And then lastly, y equals negative 5 over x. So let's just do a quick sketch of what's going on here then. So this is a reciprocal graph. The graph of 1 over x and the graph of 5 over x does that. Okay, so that's going to be 5 over x. But for negative 5 over x, you want to reflect it again in the x-axis. It does the blue shape. Okay, so you're looking for which one looks like that, and it is graph E. Okay, so let's just write this on for you. So C, B, and E. There you are. Hope that made sense to you. Moving on, question number 16. Make x the subject of this. Okay, we're kind of, including this question, we're kind of at the point in the paper where you need to be able to do all of these to make the most of your maths next year in year 12. Okay, if you're struggling with any of these, just practice and practice and practice again. Okay, they are pretty important. Okay, so question 16, make an x a subject. So I'm going to say the obvious, square both sides to get x plus 1 over x minus 4 on the right hand side. Yeah, hopefully you did that first step. And then what you want to do is just, to avoid having the fractions, put that onto that side. So you have y squared x minus 4 equals x plus 1. And then you want to expand the brackets. Okay, so you get x y squared subtract 4y squared equals x plus 1. Now when you make an x a subject, you want all the x terms to be on one side. Alright, so what we're going to do is we're going to keep the x term there and put that term to this side. So you're going to have xy squared minus x, and we're going to put that onto that side. So put all the x terms onto one side, all the non-x terms on the other side. Okay. And then to isolate x, to get it on its own, you've got to factorise at this point. Okay, that's another crucial step. Factorising this, so you get x y squared minus 1 equals 4y squared plus 1, and the last thing you want to do is to put this onto the other side. And so we'll divide that. So 4y squared plus 1 over y squared minus 1. Okay, and then that's it. That's your final answer. Okay. Next, question number 17. So this is a proof question. How do you feel about proof? I know it takes a while, doesn't it, to get used to. Okay, it's quite a difficult concept. But the thing about maths is things need to be proved. Pythagoras Theorem needs to be proved. Why does it need to be proved? Because we need to know it works for every single case scenario. Okay? If it doesn't work for every single case scenario, we can't use it. Simple as that. So the rules that we use, Pythagoras Theorem, quadratic formula, any other formula, they've all been proved to work. Okay? So proof is quite important. Okay? Prove that the difference between two consecutive square numbers. Okay? Well, look, two square numbers are basically like n squared and x squared. Okay? Those are two different square numbers. Okay? I've used two different letters. However, for consecutive square numbers, okay, what you need to do is you need to use, say, n squared and n plus 1 squared, because n plus 1 are two consecutive numbers. Now, you might have used n squared and n minus 1 squared. That's fine, okay? You'll still get the same sort of result, okay? It says prove that the difference between them is always an odd number, okay? So what you want to do is just find the difference between them. Here's a hint to you. Do the large number, subtract the small number. All right? So if you're using this and this, you can just do that, subtract that, okay? This one, I'll just write it the other way around. I'll write it as n plus 1 squared, subtract n squared. It's always easiest. If you think about it, if you do the large, subtract smallest, you'll end up with a positive value, which is kind of what you prefer anyway. And then you expand the brackets. It's a proof question, so don't take any shortcuts, please. So don't just combine that all in one go. In other words, don't just write down this. Okay, make sure you've got n squared plus 2n plus 1, subtract n squared, equals 2n plus 1. Now you've got to show why that's an odd number. You've got to say something like, since 2n is always even, because any number, or any integer times by 2 is always even, okay, then 2n plus 1 is odd. Okay, and you'll get the same result here. Let me just quickly do it for you. So you have n squared, subtract 2n plus 1. Do not forget the brackets, particularly in the proof question. N squared subtract n squared is 0. This subtract this is positive 2n. This subtract this is minus 1. Okay, and you've got the same result, effectively. Because 2n is always even, 2n minus 1 is always odd. Okay, right, I'm going to stop there. The next set of questions will be coming up afterwards. Right, this is question 18. It's a really fiddly question. It's actually pretty easy. Okay. What you need to do is make use of this result. Okay, the frequency is the area of each bar. Okay, because the actual question has labelled the entire histogram for you, including the frequency density values. So you can use your values given here and the class widths given here to work out the area of each bar. Each bar, of course, is just a rectangle. So what you're going to do in each case is work out what the width is, multiply that by the length in each case. Right? So, for example, the first bar, it goes between 0 and 10, so that width is 10. And if you count the squares, it goes up to a frequency density of 0.7. 10 times 0.7 is 7. So that's that. That's the area of that first bar. Okay? And what you need to do is work out what the total frequency is for all of these bars. Okay? Now, it says work out the estimate for people who spent between 17 and 35 minutes. Okay, so 17 minutes is about there. Okay, and 35 minutes is about here. Okay, so what you need to do is you need to work out how many people are between here and here, so the area of these three bars, and then as a proportion of everybody, so how many people in total. Okay. So let's just work through this. Best to do this one at a time, okay? So this one here, okay? So the height is 3.4, okay? And the width is 1, 2, 3, 4, 5. You've got to literally count the squares, 5. 3.4 times by 5, that gives us 17, okay? And then the next, so you've got a width there of 2 and a height of 1. 2 times 1 is 2, okay? And then what's remaining, so you see I didn't do the whole bar because I need to know exactly how many people are there. Okay, to get the whole bar, I'll just add those two numbers together. So from here to here, how many squares is it? So 3, 4, 5, 6, 7 times by 1, so that's 7. It's a bit misleading, isn't it? Because that's not 25, that's actually 24 in between the two bars. Okay, so this one here, so that is 6 multiplied by 2.5, that's the height, so that's 15. Okay, this one here, let's count the squares again, so 1, 2, 3, 4, 5. Okay, and 4.8 higher, so 5 times 4.8, that's 24. Okay, and then the last one, So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, so 10 across, 4.8 up, so that's 48. So that's the really fiddly bit, okay? But now we've got all those numbers, we can actually answer the question, okay? So proportion of those people spent between this and this, so add up those, 24, 15 and 7, so that's 29, 39, so that's 46, okay? And out of all together, so 48 plus 24 plus 15 plus 7 plus 2 plus 17 plus 7, that's 120. That'll do. So 46 over 120, or simplifies to 23 over 60. Okay? That's a prime number, so it's not going to simplify anymore. Okay? So that was part A of the question. Okay? And then there's part B. One of the customers is selected at random. Given this customer spent more than 30 minutes in the supermarket, right, let's work out that first of all. How many people spent more than 30 minutes? Let's have a look again. So 30 minutes is there, okay? So that's all of these people. 24 plus 48, so that's 72. Okay, so 72 people. So that's that, okay? So find the probability that the customer spent more than 36 minutes, okay? So let's work out that. How many people spent more than 36 minutes? So 36 minutes is about here, yeah. And so you've got to work out how many people spent 36. So from here to here, that is 9, okay? Let's just write it in here. So 9 times by the height, which is 4.8, yeah. 9 times by 4.8. That gives us 43.2, okay? 43.2 people, okay? Now, don't panic, because I know there's not 43.2 people, okay, but these things are basically an estimated probability, okay, because you're assuming it's distributed evenly among them, okay. But those are the figures we've got to use. So given that this customer spent more than 30 minutes in total, find the probability the customer spent 36 minutes in the supermarket. So what we want is the 43.2, I'm going to write my answer up here, hope you don't mind. The 43.2 out of a total of 72. I hope that makes sense to you, okay? So the probability is 43.2 people out of a total of 72. That's what the question asks us for. It's not appropriate to leave your answer like that, because there's a decimal within a fraction, you see. So just write it more simply. And I believe the answer should be 3/5. Okay? When you simplify it, 3/5. Okay? I'm hoping that made sense to you. Okay? Okay, let's go to question 19. A, it says write down a line that's parallel to y equals 7 minus 4x. So parallel means it's got the same gradient. So as long as you've got -4 as a gradient, you can have any other number apart from 7. So I mean that will do, y equals -4x, okay? Or the number 2, or the number 10, okay? As long as it's not the number 7, because they've used that, just write down a number, subtract 4x. That's part A, okay? Question B, line L has got coordinates -3, 1 and 2, -2. Find an equation of line that's perpendicular to L, passes through the point, coordinates -6, 4. First thing you need to do is work out the gradient then. So the gradient of L, and remember that's changing y coordinates over changing x coordinates. So I'm going to do 1 subtract -2 for the change in y coordinates, and then that would be -3 subtract 2 for the change in x coordinates, okay? So 1 subtract -2, that's 3, and then -3 subtract 2 is -5, so -3/5, okay? Now remember we use m to represent the gradient in our straight line equation, y equals mx plus c. So I'm going to write down m that we want to use is 5/3. Hope you've understood why. It's a perpendicular line. Remember the rule for perpendicular lines? You multiply it by -1, take the reciprocal, so 5/3. So the equation that we need is y equals 5/3 x plus c, and we've got to work out what the c is. And then we substitute in the coordinate of the point where the line passes through, okay? Careful, because it says it passes through the point in coordinates -6, 4, okay? That's the only point we know that it passes through. So if we substitute -6, 4, we're going to get 4 equals 5/3 multiplied by -6 plus c. I'm just going to work out what that's going to give us. So 5/3 of -6, so a third of 6 is 2, times it by 5, so it's -10, plus c, so c must be 14. So you've got y equals 5/3 x plus 14. Okay, but then the question says, give your answer in the form ax plus by plus c equals 0, where a, b, c are integers. So there's two crucial things there. First of all, you want the equation equals 0, which it doesn't. So you've got to put all things onto one side. Second thing is it wants integers, which that isn't. Okay, so what I suggest you do is you multiply that by 3 first of all to get them all integers. So times by 3, you're going to get 3y equals 5x plus 42. And then to put everything onto one side, you'll have 5x minus 3y plus 42 equals 0. Okay, and then that's it. That's your final answer. Okay, there's a lot of this sort of stuff going on in A-level maths. Okay, particularly this. If you found this difficult, please revise it. Okay, because you know if you can't do that, you can't do A-level maths. Simple as that. Okay. All right. Question number 20. Okay. Alright, what's this question about? Okay. Alright, the area of a rectangle is 18 centimetres squared. The length is root 7 plus 1. Without using a calculator, this is the thing, isn't it? You've got a calculator in the exam, and the exams are trusting that you don't use a calculator. Okay. Find the width of the rectangle. Okay. Well, you know, I mean, you've got the area of a rectangle's length times width, haven't you? Okay. So if you've got the area and one of the lengths, I'm hoping it's obvious that what you want to do is you want to do 18 divided by root 7 plus 1. But write it like this. Okay, write it as a fraction. Okay, this question is about surds, clearly. Okay, and what it wants you to do is it wants you to write down that and then simplify it. Okay, now when it says simplify it, okay, it means rationalise the denominator. Okay, or when it says give your answer in the form a root b plus c, where a, b and c integers, it's asking for the same thing. It wants you to rationalise the denominator. So you've got to remember the method for rationalising the denominator. How many you had to look this up? How many of you remembered it? Okay. There's a lot of this going on in A-level maths as well. Okay. So the method is you multiply top and bottom by root 7 minus 1. Okay, root 7 minus 1. Or if you want, by 1 minus root 7. Doesn't make a difference. Okay. As long as you're doing effectively what's called the difference of two squares for this. Okay. Because the idea is, look, if I show you the denominator first, you get root 7 times root 7, which is 7, and then 1 times negative 1, which is negative 1, and then you get root 7 times negative 1, and then 1 times root 7, they cancel each other out. Okay, so that's the method, okay? And on the top, you've got 18 root 7 subtract 18, okay? So that will simplify it to 18 root 7 subtract 18 all over 6, okay? And it's quite nice, isn't it? 18 and 6. So that divided by that gives us 3 root 7, and that is subtract 3. So that's it. It's just 3 root 7 subtract 3. Just check. Yep. A, B, C, they're all integers, so that's it. That's done. Okay. I hope you found that a fairly simple question. It's always easy when you see it on the board, isn't it? But yeah, you've got to be able to do that at A level as well. Okay. Right, moving on. Question 21. So diagram shows sketch of a curve. That looks like it's a quadratic because it appears to be a parabola. But you don't need to know that because it's more about transformations, this question. Okay. So you've got a graph, write down the coordinates of the maximum point with equation of y equals f of x plus 4. You've got to remember your transformations. F of x plus 4 means the whole graph gets shifted, translated 4 units towards the left. So if the maximum point 4, 6 gets shifted 4 units towards the left, the maximum point is now 0, 6. That's it. That's all it is. Okay. And the next bit, y equals f of 2x. The transformation there is it's a horizontal stretch, factor of a half in the x direction. Horizontal stretch in the x direction, factor of a half means you just multiply all the x coordinates by a half. Okay, so multiply the x coordinate by half, you get 2. The y coordinate stays the same, so 2, 6. So that's that. Part B. The equation of a curve is, I'm going to write this down, right? Y equals x squared plus 3x plus 4. And then this curve is transformed to curve S under the translation 4, 6. Okay, 4, 6. What does that mean? Okay, what does the translation 4, 6 mean? It means the 4 means you shift it 4 units right, and the 6 means it shifts upwards 6 units. So it's going 4 units right, and it's going 6 units upwards. Okay, and you can do this in any order you want. Any order you want. All right. Okay. Let's do the simple one of shifting it upwards 6 units. If you shift the whole graph up 6 units, you just add 6 to the y coordinate. Okay. So what you want to do is just add 6 to the y coordinate. So that there will just become plus 10. That covers the vertical translation. Okay. It's the horizontal translation which is a bit more fiddly. Okay. Remember the horizontal translation, 4 units towards the right, is f of x minus 4. Okay, that means translate it 4 units towards the right. What that means is you replace each of the x values by x minus 4, and that will give you your horizontal translation. So I'm going to write down y equals x minus 4 squared plus 3 x minus 4, and then of course you've got the plus 10. Okay. It does not say you have to simplify the equation. So there you go. That's your answer. But let's simplify it because it's nicer, isn't it? Okay. So simplify it. You've got x squared minus 8x plus 16 plus 3x minus 12 plus 10, and then that's going to be equal to x squared minus 5x, and then that's going to be plus 14. Right, so y equals x squared minus 5x plus 14. Okay, right, hope you found that helpful. Question 22. Okay, this is a simultaneous equations question. When two curves or a line and a curve intersect, it's simultaneous equations. So what that means is substitute that into that. This is a nice and easy one because they've already made y the subject there for you. So just put that straight away into that. Okay, so we're going to have x squared plus x plus 2 squared, subtract 2, x plus 2 equals 24. And then you've got a quadratic, an easy quadratic to solve just in terms of x. Okay, so let's expand the brackets. X squared plus 4x plus 4, subtract 2x, subtract 4 equals 24. So that's going to be 2x squared plus 2x, 4 subtract 4, and then subtract 24 equals 0. And then divide everything by 2. X squared plus x minus 12 equals 0. Really easy one, isn't it, that one? So x plus 4, x minus 3. You better found it easy, because I'm going to say the same thing again that I've said before. If you can't do this, you'll find doing A-level maths very difficult. Okay. And then your two answers then. So you got when x equals negative 4, y equals something, and when x equals 3, y equals something else. Okay, notice how I've written it. So it's obvious which answers are paired together. So using that, so x is negative 4, add on 2, y is negative 2, and when x is 3, y is 5. Okay, so that's it. Those are your answers. Okay, I think they need you to write them as coordinates, because notice in the answer space they've got coordinates written down. So just negative 4, negative 2, and 3, 5. Okay, right, that's it. Okay, question 23. This one's about vectors, obviously. Okay, so here's the diagram given to you. So you're told that is 4a, that is 2b, m is the midpoint between b and c. The question is really is, where is p? What's the ratio? It says how far along am is the point p. Okay, they give us this. Okay, if it gives us AP, so we know what that to that is. What we're going to need to know is what a to m is. If we can work out what a to m is, we can work out what fraction a to p is of that. Does that make sense? So that's our goal. We're going to work out a to m. Now to do it, what I suggest we do is we take this path, a to b and then b to m. Okay. First of all, we don't know what BC is, so let's work out that. Okay. So I'm going to write it down. BC. So BC is negative 4a plus 2b. So 2b subtract 4a. See how that works again? So negative 4a plus 2b. Okay, and then what that means is that BM is just half of that. Okay, so half of that is B minus 2a. So you can see how vectors work. You just break it up into little steps to make it a bit more manageable. Okay, so that's bm. Now we can do what am is. Okay, so a to m is that plus that. So that is, whoa, that is 4a. Okay, and then that we just had was b minus 2a. Okay, so combine it, 4a minus 2a is 2a plus b. Okay, so you've got am is 2a plus b. All right, so now what we do is we compare am with ap. Okay, and we need to work out what fraction ap is of am. Okay, now they should be parallel because they're on the same line. Okay, so that means is that that should be a perfect multiple of that. Can you see? If you look at the b, 3/4 of that. Okay, and also look, if you do 2 times 3/4, you get 3/2. All right, so that seems to work, doesn't it? So AP seems to be 3/4 of AM. Okay, so that means is that that distance is 3/4 of that distance. So as a ratio from here to here is 3 units, and from there to there is 1 unit, because that makes the 3 out of 4. Okay, so written like that as a ratio, it's going to be 3 to 1. Okay, hope that made sense to you. Question 24. This is a nice one, yeah. And you guessed it, I'm going to say exactly the same thing again. If you can't do this, practice it, because if you can't do this, you're going to struggle at A-level. Okay? A-level is so much harder than this. Okay? If you're thinking, wow, this is really hard, it's nothing compared to A-level maths. Okay? Asking on year 12, year 13. Right, so we've got to do a few things, haven't we? We've got to try and factorise that as much as possible. And we've got to combine these fractions into one common denominator. Okay? So let's just have a go at this. So the common denominator is going to be 2x minus 5, 2x minus 3, yeah? And on the top, you have 4 times that, so that's going to be 8x minus 12, and then subtract 3 times that. So subtract 3 times 2x, 6x, and then plus 15. Are you happy with why it's plus 15? Now we're doing subtract 3 times negative 5, which gives you plus 15, okay? And then this here. So look, what I'm going to do is I'm going to show a bit of working down by here. Do you mind? Okay. So the 9x minus 4x cubed. Okay. I can take x out to make it 9 minus 4x squared. And then I'll notice there's a difference of 2 squares. Did you spot that? You've got to spot the difference of 2 squares. So that gives you 3 plus 2x, 3 minus 2x. Okay. So that's that bit there. All right. And then the 6x squared bit minus 17x plus 5, that will factorise. That's probably a tricky one for you to factorise. Go for 3x and 2x. Just look, just as an intuition, because you've got 2x, okay, it's likely that something's going to cancel at some stage, so it's best to go with the 2x and a 3x, okay, as opposed to 6x and an x. Yeah, I hope you understood that. And that's a prime number, so it's going to be 5 and 1, so you've got to try whichever way around you think it's going to work. So let's just try this, because I know it's not going to work. If I do 5 and 1 like that, but 3x, 10x, you're not going to get 17i. Okay, so that was the wrong way around. Okay, so the 1 goes there and the 5 goes there. So look, 15x, 2x makes 17x. Okay, because that is positive, that's going to be minus, minus, and of course then you get the minus 15x minus 2x, which is that. Okay. And you've got to turn that into multiplication and take the reciprocal. All right. So what that means is that has got to go in the denominator. So that I had was this. So that's the denominator bit. So x, 3 plus 2x, 3 minus 2x. And then that goes in the numerator, which was this. So 3x minus 1, 2x minus 5. Okay. I'll just take a step back. Yeah. Okay, I'm just going to simplify this now, okay? Rather than write it all out again, I'm going to try and, well, I'll put it down by here, okay? So I don't forget, because if I rub that off, I'm going to forget what I had. So 8x minus 6x, that's 2x, and then negative 12 plus 15, that's going to be plus 3, okay? So 2x plus 3, all right? So let's just rub that off and write it in. Okay, so 2x plus 3. I'm hoping that you don't need any of this anymore, so I'm going to rub it all off. Okay. And then I'm going to see what can cancel, okay, what can actually cancel, okay. So, no, I don't normally do this, but to make it easy for you, I'm going to show you this way. So the 2x plus 3 there will cancel with 2x plus 3 there, okay. And is there anything else? I can see 2x minus 5 there and 2x minus 5 there, okay. Is there anything else? I don't think so, so I'm going to write down what I've got. So I've got 3x minus 1 on the top, and on the bottom I've got x, and I've got that 2x minus 3, and I've got that 3 minus 2x. And that is it. That's my final answer. I'm just going to write equals to make it slightly better. Okay. Question 25. Do you remember this? This was the sum of an arithmetic series. Okay, so the first term is a, second term a plus d, third term a plus 2d, fourth term a plus 3d, etc. Nth term a plus n minus 1d. And the total sum is this. That's what you got in your formula sheet. Okay, you'll see it again when you do A-level maths. Okay, now Mario is going to save $50 in the year 2021. So let's write that down. So the value of A is 50. Okay, he's going to continue to save up to including the year 2070. So how many terms are there? Okay, from 2021 to 2070, how many terms are there? There are 50. Okay, that's 50 whole years between 2021 and 2070. Okay, and he's going to do that by increase the amount he saves each year by k. So if I just replace the d's with k's, that is it. Okay, so they're just using letter k to represent the d there. Okay, and they're telling us that he'll save a total of 33,125. So the sum of those first 50 terms is 33,125. That's it. If you can put all that together, then you know how to do it. Because what we're going to do is we're going to use that formula and we're going to substitute all the numbers in and work out what we have. So we've got 33,125 equals a half of n. So that's half of 50, which is 25. Okay, open the brackets. 2a, so 2 times 50, which is 100. Plus n minus 1, so 50 minus 1 is 49. And we use k instead. You see that? And we just solve that, okay? So I'm going to do that number divided by 25, which I've done previously. So that's 1,325, okay? And I'm just left with 100 plus 49k. So then that means 49k must be 1,225. And then divide that by 49, that gives me 25, okay? And that's it, done. And finally we have question 26. There's a lot going on in this question, okay? Essentially what you need to know is that this shape here at the top, okay, when that gets folded around it makes a cone, okay? So see that circular arc there, the arc length AB, that ends up being the circumference of this cone at the bottom there, okay? That's important, okay? Because what you need to do is effectively do this, okay? We've written down at the bottom because that's what we're heading towards. You're going to set up an equation involving the arc lengths. So the arc length of AB, as I mentioned, okay? The formula for that is x over 360 times 2 pi r. So x over 360 times 2 pi times OB, okay? If we could work out the arc length and OB, we can do it, okay? So how do we do that? Well, OB there, that's the hypotenuse of a right angle triangle. So if we can use 25 and r, we can work out OB is. We need to work out what the value of r is, okay? So that'll be coming up shortly. But also, once we've got r, we can work out the circumference of this space, and then that gives us the arc length there. So that's what we're heading towards. So the first thing we need to do is work out what r is. Now they tell us that the height of the cone is 25 and the volume is 1,600. So using the formula for the volume, you've got 1/3 pi r squared h. We can put the numbers in and work out what r is, okay? So the volume is 1,600 and that's 1/3 pi r squared multiplied by 25, okay? If you rearrange that, make r squared the subject, you get 192 over pi, and then r is the square root of that, 192 over pi. As a check, you should get 7.81 0.17 ... Okay, but I'm going to use the exact value there. Okay, so that's what the radius is. Now using Pythagoras Theorem. Okay, we'll put that here. So OB squared is equal to R squared plus 25 squared. Now R squared is that. Okay, so OB squared is 192 over pi, and then 25 squared is 625. So that means is that OB is the square root of that, which is this. So again, that's the exact value, okay? And I'll write down what that is for you in case you got it. So that's 26.193 ... Okay? So let's just recap a moment what I said we're going to do. We want to use the arc length, but that is this, okay? Sorry, we want to use the arc length, which we haven't got yet, but we also want to use OB, which is this. I'm going to write that in now, okay? So you've got x over 360 times by 2 pi times by OB. You either use that or that, okay? I'm going to put in the exact value, okay? 192 over pi plus 625, okay? So what we need to do now is just work out the arc length, okay? That's the circumference of this circle. So I'm going to write circumference C is equal to 2 times pi times by r, which is that, root 192 over pi, okay? And that would give us 16 root 3 root pi. And sorry, but I neglected to work out what it is as an exact value. So I'm sure you can work out what it is, okay? I'm going to put that over here. So 16 root 3 root pi is equal to that. Okay, and all you need to do, is just to get x on its own. Okay, so yeah, very briefly, what you do is you type in that times by 360 divided by 2 divided by pi and divide by the square root of all of that. You should get your value of x. Okay, and then round it to the nearest whole number. Okay, now I reckon x is 107.443 something. Just check. If you've got 107.443 something, then that's a reasonable degree of accuracy. Okay, so well done. Okay, but 107 is what you need to round it to the nearest whole number. Okay, I'm hoping that made sense to you. Okay, hope you enjoyed the rest of the paper. Hope it went well for you.